Consider the unbalanced half reaction for the conversion of chloride ions into diatomic chlorine molecules in basic solution. When this half reaction is balanced using the smallest set of whole number coefficients, what is the coefficient of hydroxide ions and how many electrons are involved? To balance a half reaction in basic solution, the best way is to first learn how to balance it in acetic solution. In the case we have here, the balanced half reaction in acetic solution will have 6 electrons, 8 hydrogen ions, and 2 chloride ions on the left side, and 1 diatomic chlorine molecule and 4 water molecules on the right side. The next step is to simply replace each hydrogen ion by water. Then add an equal number of hydroxide ions to the other side. In the case we have here, we have 8 hydrogen ions. We replace it by 8 water molecules. Then add 8 hydroxide ions to the other side. At this point, we have 8 water molecules on the left and 4 on the right. The last step is to simplify by canceling water molecules that are common to both sides. In this case, we get rid of 4 water molecules from both sides. This leaves us with only 4 water molecules on the left. 8 minus 4 equals 4. And we end up with no water molecules on the right. So, the correct answer to this question is choice C. The coefficient of hydroxide is 8, and the number of electrons involved is 6. Note that for as long as we have the same reactant and product, the number of electrons involved is the same regardless of whether the reaction takes place in acetic or basic medium. Moreover, the coefficient of hydrogen ion if the reactant were to occur in acetic solution is the same as the coefficient of hydroxide ion if the reaction were to occur in basic solution. Note, however, that chlorous acid, HClO2, is a weak acid, so you should not see much of chloride ions in this reaction in acetic solution. Instead of chloride ions, we should be writing chlorous acid instead. In acetic solution, we need to fix up the half reaction to reflect this. Instead of 8 hydrogen ions plus 2 chloride ions, we should move 2 of the hydrogen ions over. Now, possible bad news. Some teachers hate this method of balancing half reactions in basic solution, so here's an alternative. Step 1. First balance all elements besides hydrogen and oxygen. In the case we have here, the only element involved besides hydrogen and oxygen is chlorine. As currently written, we have 1 chlorine atom on the left, and we have 2 chlorine atoms on the right. Balancing chlorine is a simple matter of changing the coefficient of chloride ion to 2. The next step is to balance hydrogen and oxygen. To the side that has an excess of hydrogen, add 1 hydroxide ion for each excess hydrogen. Then add the same number of water molecules to the other side. To the side that has an excess of oxygen, add water for each excess oxygen. Then add twice as many hydroxide ions to the other side. Let's look at the case we have here. On the left, we have 4 oxygen atoms. On the right, we have no oxygen atoms. Therefore, we have 4 excess oxygens on the left. For each excess oxygen, we add water. So, we add 4 water molecules to the left side. Then, we add twice as many hydroxide ions to the other side. Once we have balanced the atoms, the next step is to balance the charges. The total charge on both sides must be made equal by adding electrons. We add electrons to the more positive or the less negative side. Let's look at the case we have here. The charge on the left is due to the 2 chloride ions. The water molecules are neutral. Each chloride ion has a charge of -1. 2 times negative 1 equals negative 2. On the right side, the total charge is negative 8. It is due to the 8 hydroxide ions. 8 times negative 1 equals negative 8. The diatomic chlorine molecule is neutral. That means it has a zero charge. We can see that the left side is less negative. Its total charge is only negative 2, whereas the total charge on the right is negative 8. So we need to add electrons to the left side to make it more negative. The difference between negative 2 and negative 8 is 6. Therefore, we add 6 electrons to the left side to make the total charge on the left equal to the one that is on the right. Remember that each electron carries a negative 1 charge. Negative 2 plus negative 6 equals negative 8. So now both sides have a total charge of negative 8.